Welcome to classwork 6.5, section 5.1. This is the last section before our next test, and this is going to be going over identities and proving identities. So you might recall this from your trig class. So these first two columns, column 1 right here, column 2 right here, you should recall those pretty easily from just what we've been doing in class. This third one's going to be the really important one that I need you guys to recall, the Pythagorean identity. This is the main one. Sine squared plus cosine squared is equal to 1. If you forgot why that is, just remember the unit circle. So imagine you have a circle right here. We have a point right there. Now look at that triangle. Let's really zoom in on that triangle. So imagine you have that big triangle right there. This coordinate we've learned through trig, instead of x comma y, I can write cosine and sine, because we know on the unit circle, the x and y values correspond to the cosine and sine of whatever angle that would be. So let's convert that. This would be cosine on the bottom right here, because that's where x would be. This is sine on the top right there, because that's where y would be. And on the unit circle, the radius is 1, right? So let's put a 1 right there. And there you go. That's their proof for why that is true. That's why it's called the Pythagorean identity. Now from there, the important part about this Pythagorean identity is that this implies two other facts. This implies that sine squared theta is equal to 1 minus cosine squared theta, and cosine squared theta is equal to 1 minus sine squared theta. So after today, you should have these basic things pretty much memorized. You want to have them down to work on these identities pretty fluently. So I have a couple examples to go through with you. So the way I want you to do this is we're going to pick a side, and you want to pick the side that typically has more things to work with. So I'm going to highlight this left side. That indicates I want to work with it. You drop an equal sign right there. And the technique here is pretty straightforward. It says changing to sines and cosines, meaning you just change what you have in terms of sine and cosine. So secant, we know that's 1 over cosine x times cotan, that's going to be cosine x over sine x. Take a look at what we have. Cosines cross out, so drop an equal sign down. This next line becomes 1 over sine, and that is clearly cosecant. So we're going to box that, put a happy face. So that's what we're trying to do. We're trying to prove that one side becomes the other. So notice how I have this nice row of equals here. That's what I'm looking for in your work. And we're just working with one side again, and then you're just doing algebra to work it down. So let's try the next one. This next one, we should clearly pick the left side. There's way more terms to work with here. So drop your equal sign. The technique is clearly factoring. That's what the problem wants us to do. So factor out cosine x. That's 1 minus sine squared x. And look at that. Let's highlight this thing right here. That should be something we recall. That's the Pythagorean identity. That is equal to cosine squared. Now we have cosine cubed. Let's box that. Happy face. Done. Hey, two more. Example 4. So using two techniques. So the first technique, I'm going to pick the left side. The first technique is just called fraction splitting or separating fractions. I'll just call it fraction splitting. The idea here is if you have 1 plus sine over cosine, we just separate it. 1 over cosine plus sine over cosine. And look, we're done. Secant plus tan. No problem. Let's box that. Happy face. The second technique is I'll pick the right side. The right side is simply going to be common denominator, meaning if you have two fractions and you want to combine them, you just need a common denominator. So secant, that is 1 over cosine, plus tangent, that's sine over cosine. This is easy because you already have the common denominator, so just combine them. 1 plus sine over cosine, and look at that. that is what we wanted to do, we're done. Now it's important to note that fraction splitting works like this. All right, fraction splitting. You have a plus b over c, that separates to a over c plus b over c. It does not work like this. A over b plus c, that is not equal to this. This is complete nonsense. So make sure you guys never do something like that. You cannot separate a denominator. You can only separate the numerator. So really notice that. The numerator will get split here. Last example. So it says verify the identity. So this is going to use a bunch of techniques. We should clearly pick the left side. Let's drop our nice equal sign. So we have to do our common denominator. So notice how a little more complex. This left one needs a cosine over cosine. The right one needs 1 plus sine for 1 plus sine. So hopefully we can do this algebra in our head. That's just cosine squared. And let's make it one nice fraction bar plus, this will be 1 plus sine x quantity squared. The bottom, let's just leave that as the factored form. You want to leave it factored because we're hoping something will cancel out. Now from here, make sure you don't cancel. We have to work out the algebra first. So let's make a nice fraction bar. That's just cosine squared. 1 plus 2 sine x plus sine squared x all over 1 plus sine x cosine x. At this point, you have to be able to recognize this. Look at this, cosine squared and sine squared. That becomes 1, which means now we have 2 plus 2 sine x over 1 plus sine x cosine x. Now we can use the technique factoring, so let's just rewrite that. Let's factor the 2 out. 1 plus 1 sine x, and look at that. That cancels. 2 over cosine is clearly 2 secant x. Box it, put a happy face. Done.